The first thing that we need to do is fix a mistake in the notes. So do you see where it says the square root of I? Yeah, that's wrong. Just get rid of that. I want you to remember that the square root of -1 equals the imaginary number I. That's what it was supposed to say. Today we're going to wrap up everything that we've learned about complex numbers by solving equations involving square roots and then using complex numbers to simplify our answers. So we have x squared equals -36. The x squared is completely by itself, so to get rid of the square, we are going to square root on both sides. And when we put a square root into a problem, we have to put a plus minus in front of it, because the square root of something can be a positive or negative number. So if we introduce that square root into the equation, we have to consider both the positive and negative root. So x equals plus or minus the square root of -36. We now need to simplify the square root of -36. This can break into the square root of -1 times the square root of 36. What is the square root of -1? I. What is the square root of 36? So x equals positive or negative 6i. Done. Number 2, there's a few more things on the left side that we need to get rid of before we square root. You don't want to square root both sides until that x squared is completely by itself. So what should we get rid of first? The 26 by subtracting 26 on both sides. That gives us 2x squared equals -36. Now again, you don't want to do the square root until the x squared is completely by itself. So we need to get rid of the 2. How do we get rid of times 2? Divide by 2. So x squared equals, and I'm going to leave myself a little bit of space because I know what step is coming next, -18. Now the x squared is by itself. So to undo the square, we square root. And when we put a square root into an equation, we have to put a plus minus in front of it. So x is going to equal the positive or negative square root of -18. So I'm going to go over here to the side and take the square root of -18 and simplify it. I'm actually going to split it into 3 pieces. We've got the square root of -1. That'll take care of the negative part. Then think about 18. What perfect square could we split 18 into? So the square root of 9 times the square root of 2. The square root of -1 is I. The square root of 9 is 3. And the square root of 2 is the square root of 2. So how should we write this? X equals positive or negative. We write the whole number 3, I square root of 2. X equals positive or negative 3i times the square root of 2. Numbers 3 and 4 are the same types of problems, but now we have a binomial squared instead of just x squared. So treat that binomial like it's a plain x and get it by itself. I want you to write in your notes, do not distribute. As long as that square is on the parentheses, you can't do anything to the x and the 3. But we can't get rid of the square until the 2 in front of the parentheses is gone. So how do we get rid of the 2 in front of the parentheses? Divide by 2. That's 2 times the parentheses, so to undo it, we divide both sides by 2. That will leave us with the quantity x plus 3 squared equals -24. And notice I'm anticipating what step is going to come next, and so I'm spacing out my equals and my negative 24 a little bit. Now to get rid of that square, we square root. And if we put a square root in, what else do we put in there? The plus minus. On the left, we have x plus 3. The parentheses aren't necessary anymore because we've gotten rid of that padlock. On the right side, we have the positive or negative square root of negative 24. So again, I'm going to go over here to the side and simplify, oh my goodness, the square root of negative 24. I know it can split into the square root of negative 1, and I'm hoping we can find two other numbers. So think of positive 24. What perfect squares can you divide out of positive 24? 4 times 6 is 24. So the square root of negative 24 splits into the square root of negative 1, that takes care of the negative, times the square root of 4 times the square root of 6. The square root of negative 1 is I. The square root of 4 is 2, and the square root of 6 is the square root of 6. So we've got 2i square root of 6. Now we go back to our problem. X plus 3 equals positive or negative. Is our answer done? X isn't by itself yet. We need to subtract 3. But where do we put that minus 3? Before the plus minus. So x equals negative 3 plus or minus 2i times the square root of 6. On number 4, what do we need to get rid of first? The minus 4. Now we're talking about the minus 4 on the right. We need to add 4 on both sides on the right, like the right side of this problem. That gives us negative 4 times the quantity x minus 5 squared equals 9. How do we get rid of the negative 4 that's being multiplied in front of the parentheses? Divide by negative 4. Now, do not touch your calculators. We don't want decimals. We're going to leave this as the fraction negative 9/4. Okay, the thing that is squared is by itself. So to get rid of the square, we are going to square root both sides, and don't forget about your plus minus. So x minus 5 equals the positive or negative square root of negative 9/4. Let's take that square root of negative 9/4 over to the side and simplify it. It breaks into the square root of negative 9 over the square root of 4. So the bottom is easy. What's the square root of 4? 2. On the top, we can split that into the square root of negative 1 times the square root of 3. The square root of 9. I'm getting ahead of myself, aren't I? The square root of negative 1 is I, and the square root of 9 is 3. So on the top, we have 3i. So x minus 5 equals positive or negative 3i over 2. Is the problem done? No. What do we need to do? Add 5. We need to add 5 to both sides, and we're going to stick that in front of the plus minus. So our final answer, x equals 5 plus or minus 3i over